Good afternoon, welcome back to the chemical equilibrium class and basics. Yesterday we have seen what is the equilibrium, that is the rate of forward reaction equal to rate of chemical reaction, and it appears that there is no reaction taking place, but it is equal reactions at that particular temperature conditions applies. Interesting thing today we will see hydrogen and iodine becoming 2Hi, hydrogen iodide. Fine. We'll plot a graph and we can see the interesting this thing. This is the time, this is the concentration. So both will take the hydrogen and iodine as the equal concentration. That is the reactants are at the initial time, that is at the time 0, it will be the highest, that will be H2 and I2. It is starting like this, and we will stop here. So and at the 0 time the products are 0, then at the time of process it is going on up like this, and just we extrapolate to the where it will meet and all this thing. Here also we will extrapolate to this thing. Okay, fine. What is nothing, but the interesting thing is this is Hi. Now they reverse, they will take another experiment at the same temperatures and all, the 2Hi concentration equal to whatever the hydrogen concentration, iodine concentration. This time we will take the Hi concentration in some other beaker at that particular temperature. The curve starts from here, and whereas the hydrogen and iodine will be 0 at this point, and this is the same point, it will form a what the extrapolated curve, the same pattern curve it will form, and it will become like this, and it will be the equilibrium in both the cases, forward cases and the other experiment cases. So the thing is, it is very 100% we can say that the reactions are going on, but it will follow the same pattern, but it looks like it is stopped at that particular moment and at that particular conditions. Now, once this is established, then there are so many questions will come into our this thing. Then what is the relationship between the concentrations and all? Then how to calculate the final concentration, or in stoichiometric we can do it, but how to calculate the inertial mode, what should be the condition, because forward reaction should be the this thing. Initial concentrations, we know how to calculate the equilibrium concentrations, that is another question. Then for all these questions we will take a general formula, A plus B. A plus B is equilibrium with the C plus D. Then it is defined as Kc, equilibrium constant, equal to concentration of C into concentration of D by concentration of A into concentration of B. Fine. That is this thing. Law of mass action also, this will be it. At any instant, the concentrations of products, that is C into D, by concentrations of A into B will be the in equilibrium. They are directly proportional to the C into D, and at a given temperature, that will be the relation. Hydrogen, suppose hydrogen 1 mole if you take, and the hydrogen 1 mole they take, it will be the 2 moles of the hydrogen iodide probably form. One experiment, small experiments will be taken, that in 6 beakers we are taking 1, 2, 3, 4, 5, 6. In the different concentrations of hydrogen, iodine, and when we are taking hydrogen iodide formation and all these things, then they are following the equal pattern what we are shown in the diagram and all these things. So finally it is established that yes, we can find out at any particular time the equilibrium concentrations, and they are directly proportional to the product and all these things. Now apply this thing to the hydrogen and iodine, they find out the Kc, equilibrium constant for the above reaction. What will we are supposed to write? Hi I am writing, concentration of hydrogen iodide, and the hydrogen molecule concentration, and iodine concentration should be equal to this one. But when we found the Kc, by changing the hydrogen concentration and iodine concentration, we should get the same equilibrium constant, because it has to be changed and the ratio should be same all the time, but it is changing. So again there will be a problem. What is the problem? The problem is, say, when I am changing the hydrogen ion concentration and iodine concentration, there should be a change in hydrogen ion concentration. Kc should be always same, as long as we are maintaining the temperature and pressure and other parameters constant. But it is not so. So then they found out there is a small hitch or lacuna or confusion in this. Kc is equal to hydrogen ion concentration. Hydrogen is not hydrogen. It is not correct. The correct one is Kc equal to Hi square by hydrogen and iodine. Y square or 2 times we can write. Y means because it is the subscription is the 2. Means there are 2 hydrogen ion molecules. So it should be Hi into Hi or Hi square. So that should be the correct one. This is the finally the Kc value will come as a constant, or otherwise it will not give a. So finally what we have to define at a given temperature, the product concentrations of the reaction products raised to the respective stoichiometry coefficient in a balanced chemical equation divided by the concentration of the reactants. So if I am generalized equation, AA plus BB gives to CC plus DD, then how to write this one Kc? Kc is nothing but capital C to the power of small c, capital D to the power of small d by capital A to the power of A, capital B to the power of B. That will be the final equation. Okay, so now suppose when I am reversing the reaction, what will happen? That is meaning what I want to say, H2 and hydrogen is equal to Hi, what we have written. Now 2Hi, if I am writing H2, temperature and all I am not changing, I2. Now will it be same Kc as same Kc? Kc, H2 and I2 at the particular temperature is 2Hi, and that will be here. Now it will be the reverse. What we have to write? Kc, here the Kc for this reaction equal to H2 I2 by Hi whole square. Meaning means what? If you are comparing these two, this is 1 and this is 2. If you are comparing these two, that means the first one is inverse to the second one. The Kc for the reverse reaction is equilibrium constant for the reverse reaction is the inverse of the equilibrium constant for the reaction in the forward direction. This is for the forward direction. So it is the reverse reaction. So equilibrium constant for the reverse reaction is the inverse equilibrium constant for the reaction of the forward reaction. You have to make 1 by, that means ulta. You have to make it this one. Or now if I am writing the halves, that means if I am dividing with half, what will happen? All interesting questions. What will happen? Suppose if I am writing like this, half H2 plus half I2 gives Hi. Right. Now in this case, what will be this thing? Kc equal to Hi by H2 to the power of half, that means root. I to the power of half, that is also root. This will be this thing. Now what will be the relation between this one and this? You write some Ex or whatever, E half, something whatever it is. This and that, this will be the half of that one. So multiplying, then that will be equivalent to, therefore equilibrium constant for the reaction is equal to the Kc to the power of n. The findings are summarized. Okay, so in the equilibrium there will be small confusions. Please go through the same thing. Finally, this is to be remembered, this one, and this will be the generalized equation, reverse reaction, or half before making. Then questions will be there on this. Okay, tomorrow we will see homogeneous equilibrium and gaseous systems and all these things. Thank you.